Welcome to this explainer. Today, we're going to completely flip your mental model of cybersecurity upside down. For decades, the entire industry has basically operated on one deeply flawed premise, that to protect sensitive information, we just need to build stronger, thicker digital vaults to lock it all in. But today, we're exploring a totally radical paradigm shift. We're looking at a mathematical revolution that asks us to rethink everything by, storing absolutely nothing at all.
Okay, let's dive right into this highly provocative question. What if you could actually use personal data without storing it? It challenges the entire foundation of modern data protection. What happens if we just completely break the link between data usage and data storage? The old-school mindset assumes that to process an identity or to authorize a transaction, the underlying secret has to physically exist somewhere on a server just waiting to be checked. But what if that's exactly where we've been going wrong this whole time?
I love this quote. Before the hammer falls, the blueprint is drawn, the intent is known. It perfectly hits on our core theme today, which is addressing the root intent of security, rather than just frantically reacting to the damage once an attacker is already inside the network. See, true security isn't about building a higher wall to protect a treasure chest. It's about fundamentally changing the nature of the treasure itself, so it's literally worthless to anyone except the authorized user. We need a system that acts deterministically based on intent.
Before we get into the how, we really have to face the hard truth about the why. Simply holding on to sensitive data, personally identifiable information, or PII, is a massive, massive financial liability. According to 2025 IBM data, the average cost of a data breach has ballooned to $4.44 million. Every single record you store in a database isn't just data anymore. It's a permanent systemic risk just waiting to be exploited.
Section 1. The Password Vault Paradox. Why storing secrets is failing. Let's talk about entropy. In cryptography, entropy basically measures how random and unpredictable a password is. And for years, security teams have been forcing us humans to create passwords with incredibly high entropy, right? We're talking special characters, numbers, weird capitalization. But here's the paradox. We force users to jump through hoops creating these mathematically complex passwords, and then we completely undermine all of that effort by sticking every single one of them into one central repository. By centralizing all these highly complex passwords, we've inadvertently created a hacker's ultimate treasure chest. When we dump all our passwords into these so-called secure vaults, we create a massive single target. Honestly, it's no wonder that over 80% of data breaches stem from weak, stolen, or centralized passwords. Once an attacker gets their hands on that vault, they can just run offline brute force attacks at their leisure. The very act of storing a secret is literally what makes it vulnerable. Section 2. Nothing stored, nothing stolen. The Vaultless Revolution. So here is the big reversal we've been building toward. What if we generated the key on the fly and never actually stored it at rest? With traditional vaults, you have stored private keys and a persistent attack surface. It's basically a permanent bullseye on your network. But with vaultless security, you use live entropy. There are no static keys anywhere. The key is deterministically rederived exactly when you need it, and the split second the transaction is over, it completely vanishes from memory. Let's break down exactly how this magic works, using a framework called Secure My Identity. Instead of checking a stored list of passwords, the system generates an ephemeral key on demand. First, it gathers live inputs, like a human's master password and a totally unique identity seed. Then it mixes these ingredients using standard mathematical primitives, specifically a function called HKDF extract. You can think of it kind of like a cryptographic blender. It concentrates the entropy from these inputs to generate a cryptographic key that is perfectly accurate, yet completely temporary. Now, to protect against someone simply stealing your master password, the system analyzes adaptive identity factors as live entropy. It actually looks at your unique typing biometrics. We're talking about the exact rhythm and speed of your keystrokes. Think about it. Even if a hacker knows your password, they don't type it exactly like you do, right? This behavioral signature becomes a required mathematical ingredient to derive the key.
Keys are generated, not kept. That's the ultimate takeaway of the Vaultless model right there. We are no longer keeping secrets waiting around to be stolen. If an attacker breaches the server, they aren't going to find a database of hashes or a giant vault of passwords. They'll find absolutely nothing, because the keys literally do not exist until the authorized user is actively pressing the keys on their keyboard in their own unique rhythm.
Section 3. Tokenizing sensitive data. Protecting the crown jewels. Using a framework called Secure My Data, we can apply this same Vaultless philosophy to the sensitive, personally identifiable information, the PII, just sitting out there in your enterprise databases. We seamlessly intercept incoming data, run it through a seeded hash to generate a token, and then store that token in the database. But the absolutely crucial part here is that there is no central vault mapping those tokens back to the original data. None.
We pull this off using something called zero-knowledge tokenization. Think of it like a magical rainbow table. The original PII is replaced with undecodable tokens, and these tokens get assigned a totally harmless color index, a stripe in the rainbow, so to speak. This color tag leaks absolutely zero information about the original data. Without the protected cryptographic seed, which, by the way, is never stored alongside the data, stolen records are just reduced to a meaningless pile of color codes and random characters.
And the mathematical elegance goes even deeper than that. During processing, the data uses a super clever technique called XOR blinding. It combines the data with a random bitstream mask, almost like digital invisible ink. So the raw secret is never, ever exposed in intermediate memory. It executes in constant time to mitigate side-channel attacks, ensuring absolutely zero residual trace is left behind in the system's memory for some attacker to scrape.
Section 4. The Machine Identity Explosion. The Hidden Rebellion.
Okay, prepare to be shocked by this number. 45-1. That is the ratio of machine identities to human identities in modern enterprise networks today. 45. For every single human employee, there are 45 service accounts, APIs, cloud-native workloads, and bots. And unlike us humans, these non-human identities are sprawling completely out of control.
These machine identities, they are the perfect silent pathway for an attacker. We've got cloud-native ephemeral workloads spinning up and down all day, often relying on static secrets that developers just hard-coded directly into configuration files. There's rarely any clear human ownership. Honestly, it's an absolute administrative nightmare. And when these overprivileged credentials inevitably leak, attackers can just move laterally through automated, highly trusted paths with zero friction. So, how does the Vaultless solution tame this Wild West? Well, the fix is simple but profound. We tether every single machine's temporary access directly to a responsible human identity. We give the machine a human trust anchor, a strictly scoped mandate, and an automated revocation path. We completely stop relying on scattered, permanent secrets and start issuing short-lived, mathematically verifiable delegations of authority instead.
Section 5. Achieving Post-Breach Resilience. Winning after a breach.
These numbers really ground all this math in strict business reality. The 2025 IBM breach cost data shows that the average breach is hitting that $4.44 million mark. Got unmanaged shadow AI in your network? Go ahead and add a $670,000 penalty on top of that. But look at the savings. Organizations leveraging advanced security automation save $1.9 million on average. Vaultless security is basically the ultimate automation. It mathematically guarantees the multi-million-dollar difference between a devastating, headline-making breach and a completely harmless anomaly. The reality of post-breach resilience is that it empowers your organization to simply survive an intrusion. Why? Because the stolen data is inherently useless. Exfiltrated databases hold literally zero value. Ransomware operators completely lose their extortion leverage because you aren't storing the original data for them to threaten you with in the first place. Your security is no longer reliant on the thickness of a digital vault, but on the unbreakable laws of math. I'm going to leave you to ponder this final, provocative question as you evaluate your own organization's journey toward a vaultless future. If your systems were breached today, if an attacker downloaded your entire database, what actual value would they find? With a vaultless architecture, the answer is a resounding zero. Thank you so much for joining me for this explainer. I really hope this completely changed how you view modern cybersecurity.